So continuing on with this section on polar coordinates and graphs, we are going to work on graphing now, some simple polar equations. Let's graph. R is equal to 2, that means the radius is 2. So I want all the points that have a radius equal to 2. So every single point that is 2 units away is going to lie on the circle with radius 2. So this is what you should sketch. Now if I were to change this a little bit, and let's say make it r is greater than or equal to 2, then you would need to sketch the region of all the points that are outside the circle with radius 2. Now how about if we do another one? Theta equals to 2 pi over 3. 2 pi over 3, that's going to be a line, and here I'm going to sort of delineate where my x and y axis are supposed to be, and where the x and y axis are. This would be theta equals 0, and this up here would be theta equals pi over 2. So now you need to think about where 2 pi over 3 is. The angle 2 pi over 3 should be in quadrant 2, with this one being 3 pi over 4. If I want 2 pi over 3, that would be this right here. And know that it's going to extend back into the other side, because a line goes on forever both directions. And let me add something on here. R is between 2 and -1. Then you would not be graphing a line, but instead you would be graphing a line segment. So I'll draw it on this third one over here. If I make every circle half a unit, then I'm going to go from 2 to -1. Now this is in the direction 2 pi over 3, so that's why I go 2 in that direction and back 1 in the opposite direction, because the directed distance is r equals -1. One of the last things we need to work on are converting equations. So previously we already did point conversions from rectangular to polar and from polar to rectangular. Well, now we're going to focus on converting equations over. So let's say we have a rectangular equation, 3x plus 5y minus 2 equals 0. This is the graph of a line. This is a linear equation. But we want to turn it over into polar form. Our conversions that we use, x equals to r cosine theta, y equals to r sine theta, x squared plus y squared equals r squared, tangent theta equals to y over x. I want to write this equation in polar form, so that means I want to replace all the x's and the y's. So I'm going to write this out as 3 times r cosine theta plus 5 times r sine theta minus 2 equals 0. 3 cosine theta plus 5 sine theta, and I can factor out the r because they both have one, and then I'm going to move the 2 over to the other side. So then I can divide everything and get r equals to 2 over 3 cosine theta plus 5 sine theta. So let's try another one. What kind of graph is this? Y equals to x squared. That would be the equation of a parabola. So let's kind of see what this would look like. Same kind of thing, replace all the x's and the y's. R sine theta equals to r cosine theta quantity squared. So I need to square everything on the right side. So that's going to leave me with r squared cosine squared theta. We can divide out an r. Sine theta equals to r cosine squared theta. And then I can divide everything by cosine squared theta, so that I'll have an r equals to sine theta over cosine squared theta. We can be a little bit creative here and write this out as sine theta over cosine theta times a 1 over cosine theta. So I have r equals to tangent theta secant theta. And this would be the equation for a parabola written in polar form. Converting from rectangular to polar form, just like with converting the points from rectangular to polar, is generally easier. What's a little bit trickier will be converting from polar form back to rectangular. Let's check out r equals to 5 secant theta. So in this case, I'm going to write secant theta as a 1 over cosine theta. Then I can see that I can multiply both sides by cosine theta, which is going to give me something really useful on the left-hand side. R cosine theta can be replaced with an x. So this is an equation for a vertical line, x equals to 5. R equals to 5. This should be a circle. And circles have equations x squared plus y squared equals to r squared, and what is our radius? 5. So that makes it 25. Now how else could we have done this? Well, you could have squared both sides. R squared equals 25, and we know that x squared plus y squared equals r squared. So then we get the same equation. Now we're going to try two more. For the second to the last one, it's going to be r equals to 2 cosine theta. Our conversion equation is x equals to r cosine theta. Now we're missing an r. We can't just move the r over magically. So what we will do here is we're going to multiply and r in. That way we can take this whole thing together, and r cosine theta is going to be rewritten as our x. Now on the left hand side we end up with r squared. On the right side we have our 2 times r cosine theta. So we're just going to rewrite that first. R squared is x squared plus y squared, and then r cosine theta is our x. We can leave our answer like this, or we can move the 2x over and try to write it in standard form. If you can, always try to solve for y. If it doesn't work out nicely or you can't, something like this is acceptable. Let's try one last one. R minus r sine theta equals to 1. I know you guys are looking at this and thinking, oh look, r sine theta, that's something I know. So that's good. We can replace r sine theta with a y. Now the problem is we aren't quite done because we have r's and y's mixed in together. If we're trying to write this in rectangular form, we have to get rid of this r. So what do? We don't have any conversion equation that just has a single r in it. You either have an r cosine theta, an r sine theta, or an r squared. So which one of those three things do you think we can do? Do you think it's going to be helpful to multiply a sine theta in, or a cosine theta in? I hope you're thinking no, because if you do, you have to multiply every single term in here by the cosine theta or the sine theta. So what we're going to do in this case is we are going to separate our r from everything else. Then we're going to square everything. It's okay to square both sides. Whatever you do to one side, you do to the other. Now what's going to happen here is we create our r squared, which is good because we have a conversion equation for that, and the right side stays rectangular. I'm going to go ahead and FOIL that right side out to be 1 plus 2y plus y squared. Then I can rewrite the left side as x squared plus y squared, and then continue on with my right hand side of the equation. Now I hope you can see why I chose to multiply out the 1 plus y quantity squared. My y squareds are going to cancel. This is going to be x squared equals to 1 plus 2y. This is actually the equation of a parabola.